My name is Abhishek Jain and welcome back to the ERC standard tutorial part 4. As I explained in the previous video, the ERC standard is nothing but which is defined by the Ethereum developer community to develop the smart contract within a Solidity program, right? And in the previous video we have seen why do we need to follow these standards and what kind of advantage we will get, uh, but to just reiterate again, I mean, it's not that you have to follow this. If you will follow this, definitely you will get the advantages which is being claimed by them, and there is a possibility based on the client infrastructure where you are trying to build, where you are trying to comply with these standards, still you will get some issues, right? So in this video, I'm not just gonna explain the next standard, which I was planning earlier to just cover the ERC27, but rather I would like to just focus on the limitation of a ERC20, which I just explained in my previous video. So ERC20 standard is nothing but, where they have set of 6 methods in the 2 events, right, which we have seen. Right, but in the real-time scenario, within the if any implementation, if any smart contract which is completely compliant with the ERC20, then the limitation which that ERC20 poses is if unknowingly, if you just trigger the transaction which is going to transfer the tokens to the contract address, right? And as we know that in the Ethereum world, we have two kind of addresses, right? Externally owned accounts and the contract accounts, right? And all those things in Ethereum, we have everything, everything identified with the addresses, right? So if it doesn't matter, I mean, unknowingly, if you just transfer some ERC20 tokens to the contract address, and that contract is not defined, to just handle those tokens, right? Right. So in that case, what would happen is that contract will not accept that, and those tokens will get lost, since there is no mechanism or there is no handling at the contract that it can refuse the transaction. So in that case, what's going to happen is those transactions will be lost, and there are a lot of evidence with a lot of the implementation of ERC20 where a lot of implementation has lost a lot of tokens, right? So I'm not going to cover this blockchain concept. This we have already known, the fundamental concepts of the tokens and all this stuff, the advantages why we need to follow these standards, right? Now we need to talk about the limitation of ERC20. The very first the very first and the foremost limitation of ERC20, I just explained that if you just unknowingly send some tokens to the contract address, and that address is not, that contract is not defined to handle to send those tokens, then definitely those tokens will be lost, right? And now, as I mentioned, that there are two kind of accounts, right? The externally owned account and the contract accounts, right? And wallet address is nothing but which is connected with the externally owned accounts, which are nothing but the different parties address, right? So when you want to so what happens when you want to allow someone else to just transact on behalf of you, first you have to approve it and then you have to transfer from, right? So to get to the so that the transfer, the token which you want to approve and which you want to just give it to some other one to just on your behalf, if he can do some some transaction with those tokens, right? So that is there. So in ERC20 we have two functions or method which needs to be done. So first approve it, then transfer from, to just get just we have that transfer from, through which you will get those tokens stored or deposited within a contract, right? So if contract is able enough to just do that functionally, then it's fine. If it is not, then those tokens will be lost, right? And the another limitation is due to this fact, if you just see the implementation of Ether within the Ethereum community, what happens is this doesn't happen, that has the different implementation, so there is a fallback method through which if the contract is not able to deposit those, not able to or not designed to handle those tokens, so what happens is it just failed that transaction, or it just called that fallback, so that the transaction will get fail, and in case of the failure, those tokens get deposited back to the sender, right? Now, so what exactly ERC23 is proposing? Since we know that there is issue with the losing the contracts, and there is no way of handling the tokens or at the contract level, which is not designed to just deposit the contracts, right? So what ERC23 standards trying to solve is prevention of possibility to avoid any unintentional loss token inside the contract. Okay, possibility to send token with only transfer function irrespective if receiver is wallet or contract. So what does it mean? It means is in ERC20 we have a flexibility, we can send it our tokens to the wallet or to the contract, right? But ERC20 standards is not intelligent enough, and it goes when the transfer of tokens happens at the contract level, which is not designed to just handle those tokens, so those get failed. So now in ERC23 we are trying to just handle that situation. So there is another way, another standard which is defined by the 223. If you follow that, then you can easily handle this situation. In implementing of in ERC223, if you will see, we have only one method which will do everything by just in. I'll just explain what all logic you have to put, so that you will use only one particular method to do that transfer, either for the wallet or the contract. So in that way, there is no need to use two methods, approve and transfer from. So if you are not using two, then definitely we can reduce. I won't say it's must, but yeah, definitely. But we have seen that, not we, but it's observed by the community that gas also get reduced. And it also provides the uniformity with the ether transaction, what we have in a real ether with the Ethereum platform, right? And the another good advantage of ERC22 223 is it's backward compatible with the ERC20. If you want to know the backward compatibility, it means whatever functionality ERC20 is favoring or supporting, the same thing will happen on a ERC223 as well. So from the code level implementation, you can see the function, the light blue color, this is what the implementation ERC20, and what is being proposed. It is being proposed now, and in ERC20 we were having two arguments addressed to whom which we want to send, and then we have the value of that. But now in ERC23 we have three: to whom we want to send, how much we want to send, and along with some data, right? So that data is going to be used by the token fallback function, right? And below that in the black color you can see how the implementation would look like, right? So implementation would like this, right? Here what you are doing, if you will see this red color, you are checking whether the sender where you are sending the token, whether it's a contract or not. If it is greater than 0, it means it's a contract, and if it is a contract, then fallback has to be called, and if fallback is not implemented, then the transaction will fail. If it is there, then it's automatically handle that. So this is how you can overcome with the limitation of ERC20, right? And that's it from my side. If you have any feedback or comment, feel free to just put that in a comment section. And if something is not clear, I will be more than happy to just clear on that. If you face any problem during the implementation of ERC23, there are a lot of there is a very active community which is helping, and there are a lot of discussion I have seen over the net where a lot of people are asking why this is happening in this way, why this is implementing in this way. There are a lot of ways, a lot of other ways as well, and you can just figure it out by yourself what ways would be the more appropriate for that. Thanks for watching this, and thanks for all the support and the subscription I am getting, and see you until the next video. Happy learning and keep learning. Thank you.